Let me know if it gets laggy or staticky or anything. We're having a lot of rain in Houston today, so I'm not sure what's going to happen. All right. So this is the Measuring Density Teacher-Graded Assignment. And it's a SOAR session, so if you saw, I don't know if I emailed, but I did put a little video on the science homepage that kind of talks about SOAR sessions and why you would need to come to that. So I'm assuming both of you guys are wanting to complete this density lab and that you have not done it already. So I think we covered that and we're square there. So if you're watching this as a recording, this is a great way to go through this lab and either get help redoing it, or if you're not able to physically complete it on your own, then you have some help. All right, so we are going to take a very detailed look at the assignment and just make sure that we're able to answer everything, that we have all the tools that we need in order to get that submitted so we do not have a zero. All right, so a couple of things I want to show you. Sorry, it's showing me the wrong file, so I'm going to go through this way. I always like to show motivational quotes. So Albert Einstein says the important thing is to never stop questioning. So we will definitely be doing that in the lab today. Just a reminder on the communication guidelines, make sure you're using chat at appropriate times, and that you're focused on the lesson and not exchanging personal information. So our objective today is to complete the Measuring Density lab, do a little interaction with that, and make sure we understand it. So the first video I want to show you is a little bit about Archimedes' principle, which is the basically displacement method, how that was discovered. And so that's what we're working with, as well as measuring density of objects. So I'm going to show you that video really quickly. Let me get the link for you. So we have kind of an idea what's going on with this water displacement method. All right, so in this way, if you're not able to do this lab with the graduated cylinder and the objects, you kind of have an idea at least what's going on. So here comes the video for that.
Some of the best opportunities to learn.
All right, guys. So that gives you an idea on the water displacement method. And so, Relly, I know you just joined us. We are going through the Measuring Density Teacher-Graded Assignment. So if you have completed that, you do not need to stay. But if you have not, you're welcome to stay and do that with us. So I'm just going to share with you really quickly the page that you would need if you need to save that. I think you got prompted to save it. Then you would have it to fill out. So the next step in the lab is, well, the first step, the first activity is gathering 5 objects and measuring their mass, and then from there dropping them into the graduated cylinder and seeing the water level change, and then calculating their density from there. So this is an important step that you know how to do. I know there is a test question that shows up that asks how to calculate density, and it gives you some numbers. So if you were not able to do that experiment, here is some data that you can use. So on your page now, so I'm going to share my screen with you so you can see where I'm at. All right, can you guys see this Word document? Hopefully so. So you would be filling in the information here. It's fine to hand write it or type it. There's a couple ways that you can submit it. You can take a picture of it or scan it in if you're going to be hand writing on this page. If you want to type on it, that is okay too. All right, so that is the page that we're looking at. I'm going to go back to my data table here so that you guys can copy down this information. You've got a penny with a mass of 3 grams. And then when you drop the penny into the water, you see that it replaces or it displaces the water 1 cubic centimeter. So then you plug that into the density formula. So we know that density is equal to mass over volume. So that's how we're calculating here. You're dividing the mass of the object over the volume, and that's how we're getting this last number. So then we have a dime with a mass of 2.3. It displaces the water 1. So we have a density of 2.3. A nickel, 4.9. It displaces the water 2 cubic centimeters. And so that is a density of 2.45. And if you notice, you definitely need to have the unit of measurement for density, and you need to know what it is, and it's grams per cubic centimeter. The same kind of, if you look at the setup of the mass divided by volume, it's the same setup, grams per cubic centimeter. And the quarter is 5.1, and the volume there is 3. And the density is 1.7. So I think there's a space for 5 objects, right? And this one has 4 listed. So let me know if you guys are still with me. So 5 objects would be one that you can add on your own and just calculate out and see it yourself if you're able to. If you only have the 4, that's fine too. All right, so give me a green check if you have got your data table filled in. Perfect, thanks Riley. Cameron's ready. And Dylan's ready, great. So now we're going to answer the analysis questions about this exact experiment. So thinking of this, you can write on the board. You guys probably want to write on your paper, so go ahead and do that. But the first question is, why is water displacement an effective way of measuring the volume of an irregular solid? So irregular is referring to its shape. So why is the water displacement an effective way? Do you remember what they said in the video about the crown? So hopefully you're thinking back. All right, so an irregular shaped object means it's not like a perfect square or a circle. A crown, we know, is very oddly shaped. So it would be difficult to measure and take measurements to calculate density for an object that is shaped unusually, right? Or not very symmetrical or very, square, round. So water displacement easily just shows us the level of water it moves is its volume. It gives us the volume so easily. And then we just have to weigh the object to get its mass. And that's a much simpler way to calculate the density, right? Does that make sense to everybody? All right, so once you have an answer in, can you Put a green check up so I know you're ready to go to number 2. All right, so Dylan, you let us know when you're finished. Okay, great. All right, so number 2 is very easy. We saw this formula. What is the formula to calculate density? So all you have to do is write it out. You want to make sure that you know what all those letters stand for. And I would also encourage you to have this in your notes. And make sure you know this right here, this grams per cubic centimeter. Just as you may also see grams over milliliters. But make sure you know the unit of measurement for density. So when you're ready to move on to number 3, put a green check. And don't forget to add those to your notes. Remember, you can use notes when you take your test, so I always like to even put a sample problem or something too in notes, so that way I can see it worked out. All right, great. We're ready to go on. Number 3 says, how can 2 objects of similar shape and size have different densities? So what we saw from our quarter, penny, dime example is they displaced about the same amount of water, okay, but what was the main thing that we saw that was different with them, even though it wasn't much? Any one word pop out to you? Think back to the data table. We filled in 3 parts. And I'll word it another way. Think about a golf ball and a ping pong ball. They're both white. They're both about the same size. But they would have very different densities. And why do you think they would have different densities? You're right. Their weight is different. You can put it in chat, yes. So what would you call the weight? What do we call that in science when we're talking about it? When we're measuring something like that. Right, it's mass. So for number 3, you would write their mass is different. That could also mean they're made out of different things. One is heavier than the other. That's also ways to word that. So let me know when you have that down. All right, as we get ready to look at number 4, let me know if there's any questions on number 3. And if anyone needs more time, let me know. All right, I'm going to go ahead and go to number 4. just so that we can get through the next part, because we have another section to do. So the last question in this part says, what relationship can you see between the mass and the volume of the object? All right, so we're looking at the weight of it and the volume. So what did you see in our examples of our objects about the heavier they got? So if it has more mass, right, that's how you solve it. But what did we see as we saw the mass increase, as we saw heavier objects being used? We went from, well, a penny and a dime. The dime's a little bit lighter. But then we went to a nickel. So if you look back up to your data chart up there, what did you see as the mass got bigger? What did you see happen? Did you notice any patterns with the volume? Yes, exactly, Cameron. So the volume increased as well. So an object that is heavier, more mass an object has, the more volume it's going to have. Yep, you're right. So I would write out the heavier or the more mass, you'll see the volume will increase. So that's the relationship. You're comparing one thing to the other. So more mass is equal to more volume. All right, so hopefully that makes sense. And as you're writing that down, I'm going to get us set up here for our next little video. This is going to show us how the density of liquids works. And this is a really cool video. And while you watch this too, I'll also give you a second. You're going to need 3 different map pencils, 3 different colors. So we're looking at maple syrup, water, and oil. So if you were able to grab like a brown, yellow, and maybe blue, that would be great. If you want to go back and color that in later, that's okay too. All right, here comes this web tour. Yeah, you can get it right now. I just don't want you to miss the video. So I'll give you a second if you're going to grab something, but I don't want you to miss the video because that's basically the experiment you would be doing. So if you want to grab them really quick, you can do it. And I'm going to get the video ready to start. All right, so here we are looking at the layer of different liquids, and then some solids were added in as well. So I'm going to go through this part fairly quickly. I don't want to run too far over time. But you've got a ping pong ball. This is lamp oil. This blue is rubbing alcohol, and they colored it with food coloring. There's a soda cap floating in there, if you can see that. Vegetable oil, there's some beads in there. They colored the water green so that you could see the layer change. A cherry tomato, dish soap, milk. Dye is like one dice, that you use to play games. One by itself is called dye. And then maple syrup, popcorn kernels, corn syrup, honey, and at the very bottom is a bolt. All right, so if we're looking at these layers, we know that the heaviest things are at the bottom and the lightest things are up at the top. Okay, so they arrange themselves by their density. And so in the experiment that you were going to do, it asked you to use maple syrup, water, and vegetable oil. So you can see the maple syrup is here, the water is here, and the vegetable oil is here. Okay? So now let's take a look at the questions. So out of the three, we're answering the questions based on the three things that we would have used in the experiment, not all of these. So which liquid has the greatest density? Out of the three, we go back, out of the maple syrup, water, and oil. You're correct, the maple syrup. And so the next part of that question says why. So if you think about those three things, what would make you believe that the maple syrup, why would it go to the bottom? Yes, it is the heaviest. So you're right, Cameron, exactly. It has more mass. So that would mean it's going to be more dense. All right? So that's the answer to number one. Maple syrup, and that is more dense or it's heavier. So number two, and I don't know if you remember this from the video, you might, describe what happened when you added the vegetable oil to the cylinder. So did you guys happen to see in the video the oil go in and sink for a second, but then come back up and settle on top? Yes. Okay, good. So that's what happened. It kind of sunk for a little bit, but then it settled on top of the water. So that is the answer to number two. And then number three, how did maple syrup interact with the water and the oil? So there's obviously an order that they pour things in here. And so maple syrup would have done what with that water and oil? Right, it would have separated itself out and it would have gone to the bottom. So even if we poured the water in first, that syrup would have gone down to the bottom below it. All right, and finally, question 4. I'll wait, you guys may be writing. Let me know if you need me to hang on a second. Since I'm typing, but I'm not. I'm not sure why. So number 4, thinking about those layers in the video, if they would have poured all of those in a different order, do you think it would look different? What do you guys think? Do you think they would have stacked up differently? All right, no is the correct answer. They would have lined out exactly the same, no matter the order, because no matter the order they were put in, their density does not change. So they are still going to stack up in the order of, at the top, the least dense, all the way down, the heaviest. It's still going to sink all the way to the bottom. So that is the answer to number 4. So there's 2 parts there. How do you think? So no and why. Make sure you answer both parts. All right, so as we finish up there, that is all you have to do for that assignment. Make sure that you shade in and label your graduated cylinder. And so that is on, I believe, the second page of the Word document. Let me scroll down and share my screen. Yes. All right. So this part, make sure, if you do it on the computer, it saves it a little bit differently. So let me know that you shaded it on the computer, because sometimes it just opens up blank. But if you color it with matte pencils or crayons or markers or whatever, just label. Remember the maple syrup was on the bottom, and then the water was in the middle, and the vegetable oil was on top. And so just make sure you label those. And then you are ready to submit this document. So if you wrote on your pages, you have a couple of options. You could scan them in and save that file. If you don't have a scanner, you can take a picture. I would suggest that you hold your camera right over the top of the page, not far away, so that I can read and see the whole page, and then email yourself that image. And once you get it on your computer, you might want to see if you can convert it maybe to like a PDF, or you can upload JPEG documents. I think it'll even let you upload a PNG. So just check. And if you have any issues uploading or doing anything like that, let me know. All right. Do you guys have any questions before we wrap up? All right. Well, thank you so much for coming, and I will look forward to seeing this assignment from you guys in the Dropbox so that I can get it graded for you.